Last class period, you were led through an investigation which, if you followed it, I know it was abstract in a lot of ways, but the first part derived the distance formula, and the second part derived what the midpoint formula would be, how to find length and how to find distance. And today we're going into reasoning with slopes and length, but first I'm going to review from last class. Put it away. Trevin, put it away. Earbuds. No. I'm talking. All right. So say you're given an XY coordinate plane, a graph, and we have these 2 points. Will you shut that, please? And you're asked to find the distance between those 2 points. The whole idea behind the distance formula comes from Pythagorean theorem. Because while I can quite easily count these boxes, so 3, 6, 9, right? That also can come from the x-coordinates of these 2 points. So this is 3, 6, so this point is 6, 3, and this point is -3, -2. So if you don't have graph paper, this is how you'd have to do that. We'd have to subtract those x coordinates. So x2 minus x1. So that's 6 minus -3, which equals 9. And obviously I can count the y coordinates as well, 2, 4, 5. But if you don't have that, you'd have to subtract them to find their length. So I have my second y coordinate minus my first y coordinate. y2 minus y1. So that would be 3 minus -2, which of course ends up giving you 5. I always do 2 minus 1. If you do 1 minus 2, it's the first y coordinate minus the second y coordinate. As long as you're consistent, that's all that matters. So I happen to do this coordinate minus this coordinate. But if you do this coordinate minus this coordinate, you'll get the same results. And here's why. So we know from Pythagorean theorem that a squared plus b squared equals c squared. And you can always tell that the c value is going to be your hypotenuse, and that's the longest side. The way you tell it's a hypotenuse is that it's across from the right angle. Now the a and b, the order does not matter at all. I could do b squared plus a squared and it would give me the same results. So the way you remember these is that these are the legs of the right triangle. And if I put these values in, if I want to have a formula that just directly gives me C, I would have to take the square root of both sides, because that's the opposite of a square. So C would equal the square root of a squared plus b squared. So I applied a square root to both sides. The square cancels. Does everyone follow me so far? Stop playing with the phone up there. Okay, so a squared. We found out that that's 9 and that b is 5, right? But we can also get that from subtracting those points. So I'm just working backwards. Obviously, I can compute what that is. I'm trying to show you where this formula comes from, though. So when we subtracted the x coordinates, 6 minus negative 3, that's 9. And when we subtract the y coordinates, 3 minus negative 2, that's 5. Which is where we get this from. So we have x2 minus x1 squared plus y2 minus y1 squared. And that's the distance formula. It comes directly from Pythagorean theorem. But obviously you might not have a graph, and so you may have to use the formula. And if you just faithfully plug these in, obviously your work will look opposite of that. You would work down from this to end up with 9 squared plus 5 squared. But anyway, we have that. 9 squared is 81. 5 squared is 25. 81 plus 25, 106. My mental math is not good today. And so that's approximately 10.29. Megan, your question?
If you don't have like a graph, how do you choose which one's x1 and which one's x2?
So I could have put x1, y1 as long as these are considered one coordinate and these are considered the other.
Okay.
So it doesn't matter how you define them at all. Yeah.
Okay.
So it just has to be one coordinate subtract the other coordinate. And the thing about the distance formula that's hard to remember is that you add right in between these two. And it's not hard to remember if you understand where it comes from, which is the Pythagorean theorem. Because no one says the Pythagorean theorem is a squared minus b squared equals c squared. No, you add. It's up there. Okay, the second part dealt with the midpoint formula. Now, I can fairly obviously figure out the midpoint. If I know that this length is 9, halfway is 4.5. Very good. So I know that halfway there is 4.5. And I know that halfway to 5 is 2.5, right? So I go 1, 2.5 boxes down. So if I put these 2 points together, it's fairly obvious where the middle point is, right? But that's only helpful if we have a graph. If you don't have a graph and we want to find the middle of those 2 points, we have to add our coordinates and divide by 2. So we find their value, their total value, divide by 2. And it works when we add because we have a central point that's our origin, which is 0, 0. So that's why we're not going to subtract. But we add these 2 coordinates. So for midpoint, the big concept is that we add the x's and divide by 2, and we add the y's and divide by 2. And what you have to remember is that these are in coordinate form. So that's why it's x comma y. These are not, you don't combine x and y coordinates. So if I add my x values, negative 3 plus 6, divide by 2. I add my y coordinates, negative 2 plus 3, divide by 2. So negative 3 plus 6 is 3, divided by 2 is either 3 over 2 or 1.5. And negative 2 plus 3 is 1, divided by 2 is 0.5 or 1/2. And if I look, if I go over 1.5 and up 1/2, there it is. Okay? Conceptually, does the midpoint formula make sense? Give me a thumbs up if you're following. Okay? So whether you use distance or midpoint doesn't really matter to me. or sorry, whether you use, distance or Pythagorean theorem doesn't really matter to me. Obviously, the Pythagorean theorem works a little bit better if you have graph. The distance formula will work a lot better if you don't have a graph. Midpoint, if you have a graph, you can literally go half the length and half the length of that imaginary right triangle, or you can use the formula if you don't have that. Okay, and one last reminder on slope. Always remember that slope is rise over run, which is the change in y's divided by the change in x's. So right here, I had to go up 5 and over 9, right? And you always have to go from left to right so that you have a proper idea of if it's positive or negative. Okay, and that slope will be essential. Slope will be essential today with reasoning, because our big idea is reasoning with slopes and length today. Okay. Now, if you've been following along, this can easily serve as a toolkit entry. So up here, when we're finding length, we have length, midpoint, and slope. Another way that slope is seen, you subtract the y's divided by subtracting the x's. But as long as you conceptually understand it's the change in y values divided by the change in x values, that's your slope. Okay, so if you can't do this, we're in trouble. So here I'm going to give you a practice problem.